All right, Math 188 students, here we are. We're in Chapter 8, pretty much one of our last modules of the semester. And what we're going to do is take a look at complex numbers. And they basically consist of this number I, right, which you guys probably know as the imaginary number. All right, and usually, especially with you guys probably aren't going to be so bad, but my beginning algebra students or college algebra prep students, they look at this and they kind of roll their eyes, right? They get a little sad because they want to base themselves in reality, and here we are talking about imaginary numbers. But it turns out that this number I, actually has some very important real applications. So to make a long story short, what we do is anytime we have some sort of flow that's circular, maybe it's a nice full circle, maybe it spirals in itself, maybe it spirals out on itself, right? Whenever we have applications where there's a circle like that, right, this I magically comes up. And of course, where do these happen? Well, if I'm an F1 driver, right, in my car, right, the airflow comes off, and usually what that airflow does is it circles back behind the car. So hence we have some circular motion or in terms of our airflow. All right, so that's one area. Staying with this, sometimes we have a pipe or a river flow with some impediments, right? The river comes in with that impediment, right? We end up getting a little vortex or a flow, right? So again, we can mathematically model that vortex there, right? That's this what do we call it? Hydro flow or whatever you want to call that. Hydrodynamics, okay? And then of course, not to make it all about engineering, but if I mathematically model predator-prey models, right, what ends up happening is as the population of the predator goes up, the prey goes down. So we're somewhere in here mathematically. But as my prey model goes down, as my predator model goes down, my prey, right, the animals like deer their population goes up. So as this goes back and forth and this goes back and forth, right, it turns out that predator-prey model follows a circular pattern, right? So we basically have that. So here's some real life examples where we're actually, trying to quantify the reality, right? How much airflow do I have off my F1 car, right? How powerful in meters per second is the water flow in that little vortex there, right? At any moment in time, right? How many wolves are in the area versus how many caribou are in the area, whatever the case might be. So we're trying to quantify our reality, but right, it turns out that when I try to quantify the reality, all of these have some form of x squared plus 1 in them. I'm oversimplifying the heck out of it, but I just kind of want to cut to the chase. And this presents a problem because if I move that 1 over, we end up with something that is not real, right? There is not a real number that you can square and get -1. 1 squared is 1, and even -1 squared is 1. So this is not a real number. But here's the quandary that mathematicians and scientists found themselves at, because I'm actually seeing something in reality, right? And when I mathematically model it, I get this. So they were stuck, right? Because we want to quantify our reality, and I have an equation that cannot be solved in reality. So they were dumbfounded. So what they ended up doing is they ended up inventing the imaginary numbers. So if we take the square root of both sides, right, we end up getting that this number is the square root of -1. So the number, they redefined it. This is basically just a definition that you got to memorize, is that I is the square root of -1. And therefore that means that if I square I, what I get is -1. So that's our famous imaginary number. But it's not enough to invent a number that, kind of fits what I'm trying to do. What we have to do is we have to create a math system around it. That's well defined, right? We're able to define the number, we're able to add, subtract, multiply, divide them, as well as use them to quantify our reality. And to make a long story short, what they did is they invented the complex number system. And our complex numbers look like A plus BI, where in this case, A is a real number B is a real number. This is called the real part, and this is called the imaginary part. And what was nice about this setup is if I want to deal with reality, if I want to stay in reality, that means my B is equal to 0. There's no imaginary part. So a number like 5 written in the complex number system would be 5 plus 0i. All right, so what's nice about this is I can still do all my old math, right? Because this complex number that I've created will still work in reality. If we're basically with a true simple harmonic motion or a simple circular motion, right, then what we have is we have a purely imaginary number. So that means A is equal to 0. So if I have something like 5i, right, this is a pure imaginary number. And then if we have a vortex that doesn't quite create a circle, it either comes in on itself or spirals out. Usually in those cases, what we have is some reality mixed with some imaginary numbers. We have a complex number, all right? And so now that we've defined a complex number, right, now we need to learn to do is, kind of work with these numbers. Again, how to add them, how do we subtract them, how do we multiply them, how do we divide them? Because in any number set, right, that's what we do with any number set. All the things that you currently do in your real numbers, how do we do them with our complex numbers? Okay, so there's your introduction. We'll take a look at how to do all that. All right. Oh, actually, before I do that, I think we have enough time. It's only 6 minutes in. Let me scroll down, right? Let's just kind of use this definition just to rewrite some of the following numbers. So this is a pretty easy task. So the square root of -4, I could rewrite this as the square root of 4 times the square root of -1, right? The square root of 4 we know to be 2, and by definition, the square root of -1 is I. So -4 becomes 4/2i. Same thing with the next one, right? This can be broken down into square root of 25 times the square root of -1. So we end up with 5i. This one's a little tougher because 12 doesn't break down real nicely, but 12 is 4 times 3. So if I break this radical up, I have the square root of 4 times the square root of 3 times the square root of -1, right? That multiplies up to -12. So 4 we know to be 2. Square root of 3 is a real number, and then that's defined to be I. So that's how I would define that. So all these are all pure imaginary numbers because their real part is equal to 0. In the next round, right, we have a real part of 5, and then the square root of -1, we've defined that as I. So we now have a complex number, right, that has a real part of 5 and imaginary part of 1. This one, again, is a complex number. We have a real part of -2. Following what we did up here, the square root of -9 would be 3i. So we have -2 real parts and +3 imaginary parts. And then last but not least, right, -3 is the real part. We're subtracting this imaginary part. Well, the square root of -16, right, that would be 4i. Right, so these sets of numbers, right, are basically, we have a foot in each door, right? We have a foot in reality and we have a foot in imagination. So that means my vortex, right, I don't have a true spinning motion where it comes on back on itself. That's simple harmonic motion. In these cases, right, I have either a spiral going out or I have something where it spirals in on itself. More on this later as we end the segment. But that, 9 minutes in, wraps up your introduction to complex numbers. Let's go figure out how we add and subtract them. Talk to you later.